Hello, everybody. Today we're going to go back to Chapter 1. This is your first day with the sub. And we're going to talk about perimeter, circumference, and area in general. And this is actually a very foundational concept for second semester geometry because we do a lot of stuff with um, perimeter, circumference, area, with the circle unit. We also use it to help compute things like surface areas of 3D shapes. So I think this is something that is going to be helpful as we think about our different uh, measurements of shapes. Now, what I expect, and I imagine that probably most of you have seen a lot of these formulas, but what I expect in this course is that I'll give you a shape that combines, some of these shapes together, and that you're able to break it down into smaller shapes to compute that perimeter or area of that unseen shape. So I just want to give you that heads up. This is the most important part of this textbook section. So just being aware of those formulas. So if you know which perimeter, circumference, or area formula that you need to use, and you have the given ingredients of the information, all what you need to do is plug in to the formula and you'll be able to successfully compute that. Of course, paying attention to the units will be very important. So let's say we want to find the perimeter and area of this rectangle. So it's asking for the perimeter and the area. So what I want to see on your IP is that you are putting the formulas first. So this way I know that you're looking at the right formula and then looking for those ingredients. And you may want to be marking your length and width inside of your picture. And then when you do that, you can just immediately plug those in and you can find out what the perimeter and area is in your picture. So if you write down the formulas and you have the ingredients in the formula, it just becomes a matter of plugging it in. Another way that you can look at perimeter is just the sum of all the sides of the shape. So if we add 12 plus 5, and then this side is 12, and this side is 5, you can add that up and also get 34. But I will say that this formula is a little bit shorter when you get to those shapes with more sides. Same thing with a circle. You may want to write down your formulas. One thing that I think is useful for us is to be able to recognize that the radius is 1/2 of the diameter. So you should be able to even read a ruler, for instance, if you're computing this in real life. So radius is 1/2 of the diameter. So if the diameter is 8, that must mean that the radius is 4. And we can write down our formulas, 2 pi r and pi r squared. Now, pi is not a variable, it's a number. It's 3.14. We're going to celebrate pi on March 14th. So definitely read that tip on the side. I think that will be pretty important. You may be asked a area question or a perimeter question on the coordinate grid. Now, you may be asking, how do you compute the length of a side that's diagonal on a coordinate grid? Well, we do know what the distance is between 2 points. We can always use the distance formula. So I encourage you, anytime you have something horizontally, you can count horizontally on the graph. So like I could do 1, 2, 3, 4, 5, 6, 7 on the bottom. And I can do 1, 2, 3, 4 for my height. And I can plug in my base times my height times 1/2 to get my area. If I need to find a perimeter, I can use the distance formula and I can just plug in the points and I can get the total distance. And you can keep it in the simplified radical form, that's fine. So just add the like numbers and then keep that simplified radical from that one simplified radical that you got. For a lot of the multiple shape area and perimeter problems, I think this is really helpful. So these are some tools that you can use to be able to help you come up with accessing a word problem or a picture problem. So ask yourself what you need to solve in the problem. So write that verbal model or draw a sketch that will help you. So I think underlining key numbers, for instance, or drawing that sketch is going to help you a lot in setting up those problems. Label facts that you know or need to know in the problems. Anytime that it says the name of a shape. So on this example below, we're going to be using the area of a rectangle. I think it would be a good idea to write down the area of a rectangle formula and see what ingredients you could find. And then after that, you can reason logically, and you may want to be checking your answer and making sure that it's fitting into that formula okay. So let's look at this area of a rectangle problem. So let's say we have a part-time job at a school, and we need to buy enough grass seed to cover the soccer field. The field is 50 yards wide by 100 yards long, and the instructions of the seed says that one bag will cover 5,000 square feet. How many bags are we going to need? So we're going to compute the area of the field. So the area of a field is 150 times 300. And the bags of seed, number of bags, times the coverage per bag. So we know that each bag covers 5,000 square feet. So my reasoning then is that the area of a field is 150 times 300 equals the number of bags times 5,000, and we need to find the number of bags. So we're going to divide by 5,000 on both sides, and we see that we need 9 bags of seed. Another way that you can do this is you could just manually compute the area. So you could draw a picture if you wanted to, manually compute that area, and then do some reasoning and say that each bag covers 5,000 and divide by the area by 5,000 to get 9. Let's say that we are going swimming, for instance, and we want to find the area of a deck along 2 sides of a pool. So the pool measures 18 feet by 12 feet, and the deck is going to be 8 feet wide. And we drew a picture here to do this, and we see that it's an irregular shape. So what we did was we divided it into 3 rectangles and a well, actually, a square is technically a rectangle. I guess you could say 2 rectangles and a square. So that special type of rectangle where all the sides are the same. And so I'm going to find the area of each rectangle and the area of the square. And I know those formulas, so I'm just going to add those up, and I'm going to get, after I add it up, 304. Let's say that we have another type of problem. So we already are given the area, and we want to determine how long. So let's say we're making this triangular flag, and the base is 24 inches, and the area is 360 square inches. So how long should that flag be? So the area of a flag is 1/2 times the base times the length of a flag. We'll call it the height. And we need to think about what is provided. So we know the base, we know the area, and we just need to solve for the length. So it's telling us that that length should be 30 inches long. So I hope that this reasoning for some of these problems has been helpful for you. And I hope that these tips are helpful. And I just wanted to kind of share with you some of these tips and how I would present them in this textbook section. And I hope that you can use this video at any point while you are working on the similar problems on the IP. Thank you very much, and I hope that you have a productive day.